This video is for IM2, day 50, number 5. And what we've got here is this is going to be a really good sine and cosine review for us, and how to use it in order to find missing sides of triangles in a diagram such as this. So what we've got here is we've got triangle ABC, and CD is an altitude. And then we know the length of BC, and that is A. So we're asked first to find CD in terms of angle B and side A. So we're looking for CD, so that's this side. We know we're allowed to use angle B, and we're allowed to use A. So let's put the pieces together. Remember, if we have right triangle trig, first look at the angle you've got, and then decide what sides you have to determine if you need to use sine, cosine, or tangent. So if I've got this angle, I've got the opposite side and the hypotenuse. That sounds like sine to me. So I'm going to do the sine of angle B. That is equal to CD over A. And we're asked to express CD in terms of those things, so we need to solve for CD. So I'm just going to multiply both sides by A times sine B is equal to CD. And we'll talk about at the very end why I chose to put my A over here. There's just some interesting things when you write down with sine, cosine, and tangent functions that we just have to be careful of, but we'll talk about that at the end. So there's my answer. So CD is just A times sine of angle B. All right. Part B is asking us about BD in terms of angle B and side A. So BD is right here. All right, so we've still got this angle. So now we're using the adjacent side and the hypotenuse. So that's going to be cosine. So cosine of angle B is going to be BD over that side A. Going to multiply both sides by A again. A times cos B is BD. And there you have it. There's BD in terms of angle B and A. So part C is probably my favorite part of this problem. They give us an expression. So they give us A times sine B all squared plus A times cos B all squared. And they ask us to simplify that. So let's just try and simplify and see what happens. So that's going to be equal to, what I'm going to do first is since this is multiplication in here, right? Now remember, sine is not multiplied by b. Sine is a function, and b is the input into that function. So there's no multiplication here. This b is actually the input into that function. So don't think of that as multiplication. But this is multiplication, and when we have two things multiplied together that are getting squared, we can essentially distribute that square inside. So what we're going to do is we're going to end up with a squared times sine squared of b. I'll put parentheses in there now. And then we get a squared times cos. Actually, I'll write it both ways. You don't really need it. Cos squared b. All right? So if there's just one entry into your cosine or sine function, you don't have to put parentheses there. But one thing I do want to point out, I put my square right after the sine and not after the b. And the reason I do that is, here, I'll go up top. The reason I do that is, let's do sine of b squared. Now that looks a little weird to me, because I don't know if I'm squaring the b and then putting it into the sine function, square the b and then put it into sine, or if I've got kind of the sine of b squared, or it's just confusing. So typically what we do is we write it like this with the square here and then our input. Okay, this is the same thing. Since I've got one input, I was a little lazy and didn't put those parentheses. That's fine too. One thing I will say, if you're putting it in, I'm going to go up to the top again. If you're putting it into your calculator, you're going to need to do this. All right, so your calculator wants you to say, okay, the sine of b, parentheses, all squared. That's how your calculator is going to do sine squared b. Okay, let's get back to our problem. So now I've got a bunch of things floating around. But what do they all share? What do both of those terms share? I think they both share an a squared. So I'm going to factor, because factoring makes things look simpler. So a squared times whatever's left in there. So we've got a sine squared b and a cosine squared b. Well, that's interesting because haven't we already proven that sine squared plus cosine squared is 1? So doesn't that just become a squared times 1? So we just are left with a squared. Okay, well, let's think about that for a second. So what we just said was if I take a sine b and square it and a cos b and square it, I end up with a squared. So something squared plus something squared equals something squared. That sounds like Pythag to me. And let's see if we can relate that back to our diagram. Well, what is a sine b? If we go track our steps back, we get to here. A sine b was CD. So that's really that side. Let me draw some arrows. So a sine b is really CD. Okay. And now let's trace back this a cos b. Well, that's right here. That's BD. That's that bottom part. So that's really that. So when I take that those legs squared, so I take this leg squared and this leg squared, I'm left with whatever a squared is. Well, look at our diagram. The hypotenuse is a. So doesn't it make sense that it should be the hypotenuse squared? Yes, it totally does. So that's what they're trying to get at there is you can essentially use this for triangles. Now, we've seen it a lot in the unit circle. This is really going to lead us into doing things with triangles that don't have hypotenuses of 1. And then our last part here, why did we use a sine b instead of sine b times a? Well, that's what I said before. We have to be careful that this sine function, all these sine functions and cosine functions, they're functions, okay? So you have to be careful what you're putting after them because that's going to be the input, right? So if I had put the a on the other side, if I had written something like this, I'll put this up here with our kind of our side notes here. If I had written sine of b times a, it's hard. It's a little ambiguous, right? Am I saying do the sine of b and multiply by the a, or am I saying do the sine of whatever b times a is? So we have to be really careful. So typically we put, when we're doing multiplication and everything with trig functions, we do it all before the sine, the cosine, or the tangent.